We are now going to talk about the second important aspect of Chapter 2, which is the indifference or utility curve. So the first question that we have to ask ourselves is, what is utility? As mentioned in the previous video, utility is the amount of satisfaction that we derive from the consumption of a particular good. In the case of Chapter 2, it is the amount of utility that is derived from the consumption of a bundle of X and Y. And to be more precise in economic terms, we do not use the word satisfaction. Instead, we will use the word utility instead. The word satisfaction is meant as a placebo for you to understand what is the concept of utility. So do not use the word satisfaction. So different bundles of goods will give you different levels of utility. For example, if you have a bundle of 10x and 20y, this will give you more utility than a bundle of 5x and 10y. Well, this is most obvious because if I've got 10x and 20y at point A over here, compared to point B, I would have more goods to consume. Therefore, I have a higher utility. At point A, I am better off than at point B. So now I'm just going to imagine that I'm originally at point A and I want to compare with different types of bundles to see whether I'm better off or worse off. We have already established that point B would make me worse off. Point C obviously will make me better off because I have more of both goods. Now, what about point D? Well, I might be indifferent between point A and point D because of my preferences, and that is the same for point E as well. So that is what the utility curve is trying to tell us. Are points D and E worse off or better off for this consumer? I would now like to introduce to you the measurement unit for utility. Now, we measure utility using utils. It's like the number of liters for water, right? But the thing about utils is that it is an unobservable unit, which means that we can't see it. It is totally impossible for us to see how many utils somebody has. I mean, are you able to measure satisfaction? You can't. So that's why economists have came up with two types of utility. Now, the first type of utility is called cardinal utility. Well, using cardinal utility for economic analysis might not be that realistic because it actually measures the magnitude or size of utility in terms of utils, which we mentioned is unobservable. So using cardinal utility to analyze an economic situation would be something like this. If I take the amount of utility from having 10x and 20y and I minus that by the utility of 5x and 10y, I should have 100 utils. Is this possible? It is not. How do you measure that? And this is the reason why we use ordinal utility for economic analysis. Ordinal comes from the word order. So what ordinal utility does is that it ranks the different bundles of x and y. So it doesn't matter how much more utility one consumer derives from a different bundle. So just let me give you an example. What we care about is that the utility from 1020 is more than the utility from 510 and is more than the utility of 12. So this is an example of ordinal utility, which is what we are going to use for our analysis. So let's move on to the more important question. What is the indifference curve? Well, it is a graph that shows the many different bundles of good X and good Y, and this is the most important part, which the consumer derives the same amount of utility from all the different bundles. So therefore, the consumer is indifferent. He has got the same amount of utils for both bundles B1 and bundles B2. So for example, if a consumer has got a choice between 10x and 20y versus 30x and 15y, he can be indifferent between these two. So what we call this is indifference between two bundles of goods. And at Quickienomics, we are particular about how certain graphs and concepts are being derived. So we are going to go through how we derive the indifference curve. So you know that the indifference curve is a convex curve. We want to find out why. From your regular lessons at school, you would know that an indifference curve looks a bit like that. And U basically stands for the amount of utility. So the question is, why is the indifference curve shaped in this manner? Well, it is because of the diminishing marginal utility that the consumer derives from good X and good Y. So what the hell does this mean? Well, not to worry, I'm going to use a very simple example to illustrate this particular concept. I'm going to draw a very simple graph with my horizontal axis being the amount of burgers that I'm eating and also the y-axis is going to be the amount of utility that I derive from eating those burgers. So of course, with 0 burgers, I will have 0 utility. But what if I'm going to eat 1 burger? Let's say I've got 5 amount of utils. Yeah, but I'm still hungry, so I'm going to eat another burger. So I've eaten 2 already. The total amount of utility I get is 10. So far so good. Let's say I eat another burger. Now instead of 10, my total utility might be just 14. Well, I'm getting a bit full now, so I'm going to be forced to eat another burger, and right now my utility is 17. And by the 5th burger, I think I'm going to throw up, man. I mean, eating 5 burgers is no joke. So as you can see, the incremental utility is getting lesser and lesser. So the moral of the story is quite simple, right? If you're going to eat just 1 burger, so you consume just 1 unit of good eggs, you're going to be pretty happy, right? So as you eat more and more eggs, as you reach like maybe 5 burgers, you start to get sick in the stomach, right? So consuming too much of eggs will give you this diminishing marginal utility. So as you can see, when I substitute y for more x, I tend to get a flatter indifference curve, as you can see in the graphs right here. Similarly, if I substitute away more x for more y, I tend to get a steeper indifference curve. Well, this is all because of the law of diminishing marginal utility. So to put this into simple layman term, what is actually happening right here is that I'm gonna need more x to be willing to give up 1 unit of y. And I also need more y to be willing to give up 1 unit of x. So what you see here is referred to the Cobb-Douglas utility curve or utility function, where utility is given by x to the power of a times y to the power of b, where a plus b must sum to a figure of 1. So to think about it rationally, a consumer will only be willing to substitute x for y if the utility that he lost for giving up x is the same as the utility he gains for having more y. Well, that makes sense because he'll be indifferent if that's the case. So to calculate the utility loss in x, you have to take the negative change in x multiplied by the marginal utility of x, and the gain in utility from y is the change in y multiplied by the marginal utility of y. And since dy over dx represents the slope of any curve, in our case the indifference curve, we arrange the above equation to get marginal utility of x over the marginal utility of y. So this is called the marginal rate of subjective substitution. I'm ignoring the negative sign since the indifference curve is always downward sloping. So great, you know how to derive the indifference curve, but how does the indifference curve move? What are the dynamics of the indifference curve? Well, the indifference curve is going to move in a parallel manner towards a bliss point. So the bliss point happens to be the maximum satisfaction point where the individual can go. We know that the indifference curve would just want to keep going upwards and upwards because that just means more satisfaction for the consumer, right? So there can be consumers that prefer x to y and consumers that prefer y to x. So their indifference curves are going to look slightly different. Let's talk about the guys that prefer good y. So for the guys that prefer good y, their bliss point would be somewhere here, right? So the indifference curves will be moving more towards the top part of this graph. Whereas the guys that prefer good x would be having something like this, where the indifference curves are moving more towards the right side. So the dotted lines that you see here with the arrow tips are what we call the consumption path of the consumer. So I think you have noticed one thing, is that these indifference curves for one particular individual can never intersect one another. So very quickly, I'm just going to use a simple example to show you why. I'm going to draw 2 indifference curves, both belonging to the same individual, that intersect. So now I'm going to mark out point A, point B, and directly below it, point C. Since bundles A and B are on the same indifference curve, this means that the consumer is getting the same amount of utility from both bundles. It is also obvious that there is more utility from point B than point C, because I have more units of Y given the same amount of X. But at the same time, A should be as good as C, since they are on the same indifference curve. However, this is not the case because if A is equals to B and B is more than C, A cannot be better than C. And this is the exact reason why indifference curves for consumers of the same type cannot intersect. It will simply make no sense at all. Well, the next thing about drawing indifference curves is that you have to make sure that when you draw these curves, it is never upward sloping. So an indifference curve that looks something like this is unacceptable. You can't be gaining more utility in terms of X as you consume more because of the concept of diminishing marginal utility. So now all we got to do is to combine the indifference curve and the budget constraint, which is something that you learned in the previous video, together so that we can analyze how an individual makes certain decisions. And the step-by-step process is that we always start with the initial equilibrium, followed by an economic disturbance like a change in price or whatsoever, and then the final equilibrium. So, the initial equilibrium shows the individual maximizing his or her utility given an amount of income, nominal-wise, price of X and Y. So I'm just going to very quickly set up my initial equilibrium, and what you have to take note is of course the notations again, because you'll be awarded points for using the correct notations. So I've got my budget constraint here, and if my indifference curve is going to be here, am I maximizing my utility? I don't think so. What if it's here? Well, take a look at this point and this point. I can be on both of these points, but it's not maximizing my utility. So I only maximize my utility when my indifference curve is tangent to my budget constraint, something like this. So this is the highest level that my indifference curve can move to. Remember, the indifference curve moves towards a bliss point, right? So at point A, the price ratio is equals to the marginal rate of substitution because of the tangency of the indifference curve as well as the budget constraint. And the individual maximizes his or her utility by choosing bundles X0 and Y0. So as you can see, what stops the indifference curve from moving to the bliss point is actually the budget constraint. Well, that's why they call it a constraint, right? Notations wise, we always indicate the initial equilibrium with point A. So we move on to the next step of identifying what the economic disturbance is. To know more, please watch the video on the budget constraint because the disturbance affects the budget constraint itself. So let me just use an example of the price of X increasing so that we can get on with the video, right? So when the price of X increases to PX1, so where PX1 is more than PX0, what you get is that the budget constraint is going to pivot inwards, and you have the new budget constraint, which is the red one over there. So what happens is that the consumer's indifference curve would have to move inwards towards the origin, right? So now the utility has dropped to U1. And so the consumer decides on a new bundle, which is bundle B. And bundle B comprises of X1 as well as over here Y1. And again, the indifference curve has been constrained by the budget. So at point B, this individual's utility is maximized given I0, PX1 and PY0. So that is the final equilibrium, point B. We demarcate the final equilibrium, which is after the total effect, which is something I'll go through later. We demarcate this as point B. So that actually sums up the entire concept of how the indifference curve or utility curve works. Remember, they are the same thing. So now I just want to talk about what this total effect is about. So the total effect is basically how we got from the initial to the final equilibrium. And this is made up of two types of effects. The first one is the substitution effect, and the other one is the income effect. So you need both of these effects to create the total effect, which brings the consumer from the initial equilibrium to the final equilibrium. So this is where I introduced the concept of the Hicksian, just a spelling error there, the Hicksian and the Slutsky definition of real income. I'm going to go through this in just a little bit, so hang in there. So I'm going to use the analogy of this pink little guy that's going shopping. While she's out at the shopping mall, she realizes that there is a 50% sale on good X. Well, this might be something that's good for her, so let's take a look at what is her decision-making process as to whether she buys more or less of good X. So how I like to remember this is that I know that this individual is going to be so excited about the sale. So excitement is an emotion, right? So the emotion aspect is always the first thing that will go through this individual's mind when it comes to decision making. So since there's a 50% discount, she's gonna tell herself, oh man, this is great, I'm just gonna buy more of good X. And then what happens? She's gonna look into her wallet and she's gonna start counting her money, and she starts to think, so I've got this amount of real income after the price change, so should I buy a lot more X? Or just a little bit more X? Or maybe I should buy less X? What kind of good is X to me? So as you can see, she is starting to look at her income. This is the rational part of her coming true. So after considering her change in real income, she makes the decision of how much to change her quantity demanded of good X. What you've just seen here is the entire process of the total effect. And again, the total effect is to get her from the initial equilibrium to the final equilibrium. Let's talk about the first effect, which is the emotional part, and this is the substitution effect. Recall what just happened. She was so excited that it was a 50% discount that she automatically told herself that she would buy more. So as you can see, when there's a decrease in price, what you get is that this individual is going to automatically demand for more X. And of course, if you're going to go the opposite direction, when the price of X increases, I think the first thing that comes to your mind is that you'll be so turned off, you will want to buy lesser X. So as you can see, in the substitution effect, the price of X as well as the quantity demanded for X moves in opposite directions. So what do I mean by opposite direction? So if you look at this graph over here, and if this individual was initially consuming X naught amount, a decrease in the price of X would make this individual want to consume more X. So he moves towards the right. So the substitution effect is in the right direction. If the price of X were to increase, the substitution effect moves in the direction of left. So moving away from the emotion analogy, let's look at how we can explain this in layman terms. So the substitution effect causes the individual to change his or her bundle based on price. And we also mentioned that she has not considered her change in real income. So this change in quantity is based on price given the same amount of real income. So how do you determine what is the original real income now that prices have changed? And furthermore, the individual has not realized this yet. So how do you identify what is the same amount of real income to this particular individual? The key idea to determine what is the real income is to make sure that this individual is as well off as he was previously before the price change. So what do you think of when I say the words well off? Do you think of utility? Or do you think of quantity? Which one should be the base of which we determine what is the initial real income? And this is where the Hickson analysis as well as the Slutsky analysis comes into play. We will be using more of the Hickson analysis in this syllabus. Now that we're halfway through the total effect, let's talk about the income effect, which finishes the entire process. So exactly in which direction does the income effect goes? Well, this actually depends on what type of good is good X. Is X a normal good or is it a inferior good? So whether a good is normal or inferior depends on the relationship between real income and quantity demanded of X. So for a normal good, if my real income were to increase, I would increase my demand for X. Well, that's just normal, right? If I'm richer, I want more. And if my real income were to be lesser, I would demand for lesser X. If I'm poorer, I will buy less X. Very normal. But for an inferior good, if my real income were to actually increase, I would demand for lesser X. Well, that's weird. And if my real income were to decrease, I would actually demand for more X. So why does this happen? What would be a good example to illustrate this? So let's say I've got food from a classy restaurant, and I'm going to compare this with food that I get from the regular coffee shops around, the neighborhood. So imagine if you had more money right now. What kind of food would you want to eat? Well, I'm very sure that most of you are going to say that, oh, well, of course I'm going to have more restaurant food. But think about the people who are thrifty and, maybe they work their ass off for their money. So if I'm somebody like that, I would prefer to eat more regular food because, I want to preserve my wealth. So that's the difference between the normal and the inferior good. It does not say anything about the quality of the food. I mean, I've eaten some regular food that tastes much, much better than the food that I get at restaurants. So let's begin with the Hicksian definition of real income and how we use this definition to actually craft out the entire total effect on the graph. So according to Hicks, the definition of real income is derived from utility. Therefore, to put this consumer on the same amount of real income is to simply put him on the same amount of utility. So if you think about this, same amount of utility, well then obviously you have to put this individual back at the same utility curve. And that is exactly how we are going to find the substitution effect under the Hicksian definition of real income. And after we have marked out the substitution effect, we are going to find out where the income effect is. And of course, this depends on whether good X is a normal good, inferior good, or in the future, we're going to talk about given goods. So enough of my technical mumbo jumbo, which was meant to give you a better understanding on why we're drawing these lines over here. Just let me set out my initial equilibrium before we identify the substitution effect as well as the income effect. Let's just say, for example's sake, that the price of X has gone down. So what happens to the budget constraint is that it is going to rotate outwards, as you can see here. So we've got I0 over Px1 and we have a new price ratio. So you know that the new bundle, point B, can lie anywhere here, right, within this region. So why can't it be here? Well, because if it's here, then my indifference curves are going to intersect there. And well, this is not going to make sense. This is going to violate the economic theory. That's why point B can't be there. And point B can't be here as well because, well, you're going to have another intersecting indifference curve. So for Hicksian, the first step will be to draw an imaginary budget line which is tangent to the old indifference curve, and this budget line has to be parallel to the new budget constraint. So we call this the imaginary budget line. Take note, same utility curve, parallel to the new budget constraint. So we're going to demarcate this as point C. Well, I know it's weird that it's point C, but that's the notations used in the subject guide. So the individual will be at x1 given the substitution effect. Alright, so I've did it. I've marked out my substitution effect. So I'm just going to draw an arrow there which points towards the right direction and label it SEH, which stands for the substitution effect given the Hicksian definition of real income. So from point C, I know that if I move to the right side, X is a normal good. And if I move to the left side, X is an inferior good. So I just wanted to chill here. I'm very sure you'll be asking me how the hell did I know this. So don't worry, I'm going to explain this in the next video. So just stay calm and just take it as it is first. Let's say good X is a normal good and point B happens to land there. So what I'm going to do is I'm going to mark out this as X2. And my total effect, of course, will be from A to B, right? And from C to B, that's going to be my income effect. So as you can see, this total effect from A to B is made up of the SE as well as the IE. Well, what if B is an inferior good right there? So I'm going to do the same thing, and I'm going to mark out this as X3, and my income effect is going to be moving towards the left direction instead. So that is the income effect for a inferior good. So you did it. See, it's easy, right? You've just marked out the substitution effect under the Hickson definition of real income, as well as the income effect given a normal as well as a inferior good. See, it's easy. So just let me do it one more time so that this will reinforce what you just learned. Instead of a decrease in price, I'm going to have an increase in price of X. So I'm sure after watching the previous video on the budget constraint, you know that an increase in price of X will actually cause the budget constraint to pivot inwards, just like this. So take note of the notations, and I'm going to find out what my total effect is now. The first step, of course, is to draw your imaginary budget line, which is going to be tangent to the same indifference curve, and of course it has to be parallel to the new budget constraint. So I've got point C. I'm just going to mark out point C over here, and there you have it. You already have your substitution effect, which goes in the left direction, and I'm just going to mark it out as SEH. So from point C, if I'm going to consume lesser X, I know that X is going to be a normal good. And if I'm going to consume more X, then it is an inferior good. So it really depends where point B is going to be. So if let's say point B is here, which makes X a normal good, I'm just going to draw my income effect. As you can see, there we go. So I'm going to label this as IEH. So I've got the income effect for the Hickson definition of real income for a normal good. So what if point B is here, and that makes point B an inferior good? So I'm going to do the same thing. I'm going to mark out my income effect, which is now the opposite direction of my substitution effect. And there I have it, my income effect for a inferior good. See, it's actually quite easy, right? So what's going to happen next is that I'm just going to very briefly touch on the Slutsky definition of real income. Well, you're not going to be tested on this much, so I'm just going to touch on this a little bit so that we complete the syllabus. So for Slutsky, his definition of real income is to get the individual back to the same quantity that he was consuming. So you have to bring this individual to the initial bundle of X and Y that he initially was. The reason why we have the Slutsky definition of real income is because if you're going to take the old prices multiplied by the old quantity and compare that to the new prices and the new quantity, these two might not be the same. So if these two figures here are not the same, that means the nominal income has changed, which obviously cannot happen. So to identify the substitution effect under the Slutsky analysis, we need to put the imaginary budget line across point A. And then after that, the income effect is pretty much the same. It depends on whether good X is a normal, inferior, or a given good. I'm not going to talk about the type of goods for the Slutsky analysis because it is a little bit less important. If it happens in any of the questions, I will go through them in separate videos. So, one disclaimer, do not use the Slutsky analysis for your exams unless you are instructed to do so in the question. So I always start my example by establishing the initial equilibrium, and I'm going to assume that the price of X is going to fall. So from the basic, the budget constraint is going to rotate outwards. So what we usually do is to draw the imaginary budget line, right? But instead of drawing it tangent to the indifference curve, we make sure it's going to cut through point A. So that is what I mean by bringing the individual back to the initial bundle. So the Slutsky analysis requires an additional step. I have to draw another indifference curve to actually identify my substitution effect. So if I were to move a little bit upwards, I would get point C, right? So from point A to point C is where my substitution effect under the Slutsky analysis is going to be. So I'm moving in the direction towards the right. And we're almost reaching the end now. So let's say point B happens to be here. And picking up from where we left off, the income effect under the Slutsky definition is simply from point C to point B. So there you have it. I've already defined the entire total effect for the case where price of X has decreased. Well, now that that's done, I just want to remind you that the economic disturbances we've been using is simply a change in the price of X. Well, what if it's something else? What if it's a change in nominal income? What if it's a lump sum subsidy? Or maybe a lump sum tax? Do you think in this case there will be a substitution effect and an income effect? Well, think about it clearly before you proceed with the rest of the video. Well, I sincerely hope that you have actually given it much thought. So what happens to the budget constraint when there's an increase in nominal income? So let's take a look at this. We know that the budget constraint is going to shift outwards in a parallel fashion. So there we have it, we have our new budget constraint given an increase in nominal income. So we're still using the Hicksian definition of real income. Take note that prices have not changed. So if I'm going to draw my imaginary budget line, it's going to be the same as my old budget line. So point A is also my point C. And what this means is that there is no substitution effect. Remember that substitution effect is changing the bundle based on the change in price. So if there's no change in price, how can there be a substitution effect? So moving from A, which is also C, to point B would simply be the income effect. So the total effect is made up of only the income effect. So as you can see in the graph right here, I am showing the income effect in a case where there is a normal good, and for this one, in the case of an inferior good. So I'm just going to mark that out clearly to show that this is the income effect. So there you have it. Make sure you do not demarcate any substitution effect. So the moral of the story is quite simple. If there's no change in price, then you have no substitution effect. It is only the income effect that makes up the entire total effect. So I hope you've enjoyed this video, and in the next video we're going to go through more exciting stuff. From the skeleton cartoon figure in the pink hoodie and the rest of the team, thank you for studying with Quickienomics.